For this, I have three curves listed here, right? All the three curves of which the very first curve you can very clearly recognize it's nothing but sin x curve. So where do I have my cursor as? Yeah, okay, fine. So the very first curve that we have in front of us is nothing but sin x curve. And I can call it as f of x equal to sin x. So f of x is equal to sin x. Now, for all the curves, I'll just make you understand this. If I have a curve of this kind of simplest curve, say sin x curve, what do you see from this point to this point? You see that the curve is increasing. How do you say so? When you draw a tangent at any point to this curve, say I draw a tangent here, right? You see the slope of this tangent. The slope of this tangent is positive. Why is the slope of the tangent positive? Because very simple funda. This is the line, something of the same kind. It makes an angle theta, right? Which is nothing but acute angle, and tan theta acute, that is in first quadrant, is positive. That means we know that the slope, which is nothing but tan theta, is positive for such kind of line, right? So here from this point, so now reflecting the same thing on the graph, what do I understand here is here for this part, from this point to this point, what do I see? I see that the curve is increasing. I hope that's understood now with the help of this explanation, right? So the curve is increasing. The curve is increasing. That means its derivative has to be positive. The curve is increasing. Done? Okay. So from here, okay. Apart from this, when slope is positive, that means how do you relate slope to the derivative? Last lecture I said dy by dx is nothing but slope or the gradient of the tangent, right? So let's not get into very depth slope gradient of the tangent. Let's now keep it simple. Dy by dx is equal to slope, and we know that the slope is positive. So here curve is increasing from this point to this point. Again, from 0 to pi by 2 in our curve, if you can just check out from 0 to pi by 2, the curve is increasing, slope is positive, hence derivative is positive. I hope I have made my point. Derivative is positive. So now the same thing, the next graph that you see, this brown color graph that you see, that is nothing but derivative of it. Just check. From 0 to pi by 2, derivative is positive. Derivative is positive. Just write it down. Derivative is positive here. Here derivative is positive. Why is it positive? Obviously this white line means the axis above which it is positive, below which it is negative. I hope that's very clearly understood, right? Okay, and why the curve this way? Why the curve this way? I'll make you understand that also. So the curve is increasing. Now I'm talking about the blue curve again. The curve is increasing from 0 to pi by 2, right? So here the derivative is positive. That is understood. That means the derivative would be above the white line. Done. And what do I understand next is, so attains its maximum at that point. If you draw a tangent. So here, where am I? Here. If you draw a tangent, just check this. If you draw a tangent here, what do you see? You see the tangent is parallel to the x-axis, right? So at this point, so let me just name this point as P, right? So at point P, what do I see is that the derivative at this point would be equal to 0. Why? Because slope of the line at this point is 0. Do you agree this? Right? So derivative of this point is 0. So at this point P, pi by 2, you just check out at point pi by 2, the derivative is 0. So derivative is positive. It becomes 0. And then from pi by 2 to pi, just check out from pi by 2 to pi. The curve is decreasing. Now when you see the curve is decreasing, it is falling. See, this is the curve. The curve is falling. And at any point, if you draw a tangent, Why tangent? Because tangent gives you slope. That is nothing but the derivative. So if you have a line of this kind, right, comparative to this, here I draw a line, So this line makes an angle theta. Here, when you see this, theta is nothing but obtuse. That is more than 90. Tan of obtuse angle would be negative, as we know. So in short, I can just say when the curve is decreasing, right? the slope or the gradient is negative, and hence the derivative is negative. So hence the derivative. So here I come to the point pi by 2 to pi. The curve is decreasing. So when the curve is decreasing, it is in fact decreasing from pi to 3 pi by 2 also. But it is decreasing. So the curve is decreasing. The derivative has to be negative. I hope I have made myself very clear. So 3 important points which you need to understand. Here, where am I? Here. Okay, fine. The very first point. Curve increasing. Curve increasing, that means this part. This part. Curve increasing. So slope positive. That means derivative positive. Next thing. Curve decreasing. Curve decreasing. So the slope negative. So derivative negative. I hope this is very clear. At this points, the points where it attains its maximum or minimum, it applies for minimum part also. Applies for minimum part also. So where it attains its maximum or minimum. So if you check out here at this particular point, again, what do you see? You see that the tangent, see this thing. The tangent is again parallel to x-axis. Hence the derivative is again 0. So at point P, at point Q, where it attains its maximum or minimum, when it attains its maximum or minimum, what do you understand here is the derivative is 0. Check this. The derivative is 0. Check this. The derivative is 0. Check this. I hope that part is understood. So at point P and Q, the derivative is 0. Now this point are known as stationary points, right? So here I come to saying that points P and Q are known as stationary points. At this points, the derivative, yani f dash of x is equal to 0. Right? So I hope I have made you very clear with the curve, as I said, is f of x. Then this is nothing but f dash of x. So here we check it out as to where is f dash of x. This brown curve is f dash of x, means it's a derivative, right? And we know derivative of sin x is nothing but cos x, yeah. And you check out the graph also. The graph completely represents cos x. I hope that is understood. At cos pi by 2, it is 0. At cos 3 pi by 2, it is 0. I hope that's understood. Right? Ignore this 5, 10 as of now, because those also can be very clearly understood. But don't get into details of this. Better is this part. I hope this is understood, right? Now, I'm more interested in another two things. That is, once I have f dash of x, I want to go further with this green curve. What does this curve mean? Again, from this point, when I say this, okay, this point, right? So this is again 0. At this point is 0 to pi by 2. What do you see? The curve is decreasing. Now the curve is decreasing, its derivative has to be negative, and you see this thing. It is decreasing right from 0 to pi. So the derivative of it is negative. The derivative of this thing is negative. So what do you see here is the derivative is negative. Then comes the derivative positive. Here. So derivative positive, again derivative negative and derivative positive. Right? So this is nothing but derivative of this brown curve. Done. So I would obviously say that this is nothing but f double dash of x. So here comes f double dash of x. Right? And cos x ka derivative is nothing but minus sin x. And this completely reflects. What does it reflect? You see the blue curve and the green curve. Blue curve and the green curve. Blue curve is sin x, and it's minus f. If this is f of x, then this is minus f of x from the curve. You see the reflection, minus f of x, right? So if this is sin x, this becomes minus sin x. I hope you understood the logic, right? So we come to a conclusion that f double dash of x is minus sin x, and you see as minus sin x curve here, right? Again the same logic, just check out. From 0 to pi by 2, the curve is decreasing. Further from pi by 2 to pi by 2, it is decreasing, right? At point pi, it is maximum. At maximum, so its derivative would become 0. So derivative becomes 0. At again 2 pi, here, my bad, earlier it was minimum. So now it's maximum. It again becomes 0. Here it becomes 0. So between that, negative, 0, positive, negative. I hope that is understood. Clear? So that was a basic understanding here. I have given quite a lot of this here to understand this. Curve increasing, slope positive. I hope that is understood. Slope positive, so derivative is positive. At point P, it is 0. Curve decreasing, so slope negative, so derivative is negative. P and Q are known as stationary points. I hope this all is understood, right? Okay, apart from this, here you have this curve. See this, right? So you see this, the curve is increasing. This is stationary point at which derivative becomes a 0, right? So I can always say derivative at this point is 0. So derivative is 0. dy by dx it becomes a 0, right? Again, dy by dx at this point also becomes a 0, right? This is your curve. Now, this is your increasing curve. The reason I gave. This is your decreasing curve. This is your increasing curve. Understood this? Right? Here you have a horizontal tangent. Right? So that is understood. Right? Okay. So I suppose this all is clearly understood. Okay. You have a question here given. Right? Just try this question and post me the things as to what did you understand here. And I'll reply to this part. So this is a question for you. Find and classify all stationary points and inflection points of this thing. Okay. What are inflection points, by the way? Now, inflection points I would say point of inflection, right? I'll have a detailed lecture on inflection in the next part wherein I can go with the details, but as of now, just to make you understand, point of inflection occurs where f double dash of x is 0 with the condition that whichever point it occurs at, that means if this occurs at a point x1, f double dash of x1 is 0. For example, at this point, you see this point, at this point, this is 0. You see the cursor. At this point, double derivative is 0, right? So before and after, double derivative should have opposite sign. So f double dash of x1 is 0, right? Before and after. So I would always say, if I just change this point as pi. Do you understand this? See this. F double dash of pi is 0. So before and after that point, so f double dash of pi minus any small quantity, right? And f double dash of pi plus any small quantity. At this point, you see it's negative. At this point, you see positive, right? If that happens, then we say this point pi is a point of inflection. So x equal to pi is point of inflection. It could be inflection this way or inflection this way. Right? I hope you can always ignore this English. That's not important to us at all. Right? I hope this is understood to everyone. Clear? So this is a curve. Go through it. Right? Understand point by point. There's quite a lot of theory to it.